All right, so this is going to be rapid fire 5. Two algebra problems. The first one, I want to make a point about something that you should do in class. Try to remember to do. It's all about seeing patterns, and that strengthens your mathematical mind. It's the whole study's based on patterns. So you want to get as much practice looking for patterns as possible. And this is a nice problem that displays that, how looking for a pattern can cut down on your effort. So people had trouble with this. Some people got to it during their workshops. Other people, I don't recall having any conversations or seeing some other folks work on that problem even, which means you got to redouble your efforts in class. I noticed that there were a number of answer keys left on my desk after the second test, after B block, about 10 to 12 of them. I'm wondering who's not even taking the answer key. And I don't know how you're going to learn from your mistakes if you haven't got something to work with. So anyway, got 25 more class days, probably 7 or 8 tests, which means you got about 15 to 20, somewhere in there, class days, depending on how many we actually get to, how many days we actually get to test. So we're getting down to the part where I have to determine whether you're ready for calculus or not. And the scores currently suggest that many of you who signed up for it, I will not let you take calculus unless your scores go up. I have no doubt they're going to go up. There's very little doubt that with this much time, that problems on that test can't be figured out by you. All right, so let's get one of them that you had trouble with out of the way. So 5 in a row here. All right, my computer doesn't allow me to say plus minus, so they're going to come at you more like this one, where it's just a plus or a minus. All right, so what do we got? Our goal is to get ax squared plus bx plus c equal to 0. And if you can complete the square and get an answer, what's preventing you from going in the other direction? Plus or minus, oh, sorry, I meant to say 2i, plus or minus 2i, x minus 3, I think plus or minus 2i comes from plus or minus the square root of negative 4. So getting rid of the square root gets us x squared minus 6x plus 9. And that equals negative 4. And so therefore our answer, and we're going to put it right up here. Our answer to this problem is x squared minus 6x plus 13 equals 0. Geez, I wonder what I might do with this number on the next one. Maybe double it and change the sign. 3 squared and 2 squared. Well, that's 13. Oh, does that mean over here that the answer to this one is 0 equals x squared plus 10x, 25 and 16, 41? Geez, if I put a little effort in, it seems like I can maybe do that problem effortlessly and not have to actually write anything out. Let's find out if it's true. Maybe I'm wrong. X plus 5 equals plus or minus 4i. All right, so squaring both sides, x squared plus 10x plus 25 equals 16 minus plus or minus. Let's do this so that everybody can see what's going on. Plus or minus squared is positive. 4 squared is 16, I squared, which we know is negative 16. So it looks like I can bring x squared plus 10x plus 41 equals 0. Oh, yeah, hey, that's true. I guess it was. So let's try the next one. Let me get an eraser here. Clean up the board a little bit. I already got the cubic discussion on the front board, so that's why we're over here. So we're at this one now. Yeah, you can see that fine. So it looks like this is going to be x squared minus 14x, 1 and 49 plus 50 equals 0. Let's find out if that's true. I'm going to do the work over here. I'll do it here. So we got x minus 7 equals plus or minus I. This becomes x squared minus 14x plus 49. And that's equal to I squared. I squared is negative 1, so we're going to add 1 to 49. Oh yeah, we get that. All right, so what are we going to get here? I'll do the work with you. You certainly should be able to, after what we've been talking about, maybe just write your answer, but x minus 10 equals plus or minus 5i.
Squaring both sides gets us x squared minus 10x plus 100 equals 25i squared. We know that's negative 25, so it's x squared minus 10x plus 125 equals 0. All right, and what I think I'll do is go backwards on this one, go and get that answer that we started with, because this is also on your test. How do you do it? You work with the geometry of the first two terms, you complete the square, you take that rectangle, and you have a rectangle, you even off the sides, which means you're cutting that number in half. You also do that when you do circles. So this becomes x minus 5 squared minus 25 plus 125 equals 0. That's 100, goes to the other side as minus 100. This side is x minus 5 squared. We take the plus minus square root, and you get x minus 5 equal plus minus the square root of negative 100. And therefore, we have x is equal to 5 plus or minus, that's what, 10i. And that's where we started with a moment ago. All right, one more. Let's see if we can correct this. So I've got x plus 4. Let's go up here with it. All right, x plus 4 equals plus or minus 7i. We probably can say minus 49 at this stage. Maybe you're starting to see the patterns here. 8x plus 16. And so therefore we have x squared plus 8x plus 50 and 60, 86, so 85 equals 0. All right. Now I didn't think about that. I didn't even look at the numbers. I might have made a careless error on the last one, because honestly, I just perfunctorily went through it. All right, now we also have another problem. It's an algebra 1 problem. It's an important algebra 1 concept, and I will try to develop it for you right now. All right, and I'm going to call it Bingo-Bango-Bongo because it's in honor of Mike Tatishev. Taught me this many years ago, and it's actually a good thing to remember. It's come in handy over the years. So let's look at it. So 1/2 and 1/3 adds up to 5/6. All right, so that's what that adds up to. Now I could have written the number 1 as let's see, 1 plus 1 over 2. Now I can't do that. Oh, 5 minus 4. 5 minus 4 is 1 over 2. Plus, and the number 1 could be 7 minus 6 over 3. That still has to equal 5/6. Bingo, bango, bongo is all about cross multiplication. I mean, we know that we're going to multiply by 3 and 3 and 2 and 2 the old school way, right? So if I know that, why can't I just look across and get that multiplication by 3? All right. And then add, look across, get that multiplication by 2, and then do 2 times 3. All right, so here's bingo. 3 times 5 is 15. 3 times negative 4 is negative 12. 2 times 7 is 14. And 2 times minus 6 is minus 12. And 2 times 3 is 6. 15 minus 12, I'm going to go up here. 15 minus 12 is 3 plus 2. And that's 6. And yes, mechanics of that work. Now, where are we having our trouble? We're having our trouble right there. And that's why I said algebra 1. Because if you're going to subtract something or add something, you got to add both parts. If a number is written as a couple of different parts, you got to add both. Or if it was subtraction, then we get 1/6 for an answer, I believe. Let's find out. I'm not really thinking about this too much at the moment. So we still have 3. We have, I didn't do the multiplication. So 2 times 7 is 14. 2 times minus 6 is positive 12. A little sign change. Yeah, and 3, 12s cancel. 3 plus 14. I got lost in that somewhere. All right, you can figure out where I got lost. It's early morning here. I'm just going to do a quick bingo bango. X minus 2 over 3 minus x plus 4 over 5. All right, so start by actually putting in your framework here. All right, that doesn't take any effort. So 5 times x, 5x, 5 times minus 2, minus 10. 3 times, the minus sign is already written. So 3 times x is 3x. 3 times positive 4 is positive 12. And that's going to be 3 times 5, 15. If you get to that point, I have every faith that you're going to get a correct solution. So you got minus 10, minus 12. You're going to get minus 22. 5x minus 3x, 2x, over 15. And then you look to see if there's any common factors that you can divide out of the problem. I'm going to go back and do my 1/2 minus 1/3 later to find out where, the numbers went astray for me. Could be just old age. All right, next one. So let's do 3 or 4 of these in a row and just the mechanics of it. So let's look at 2x minus 5 over 3 minus x minus 2 over 7. Bingo, bango, bongo. Do that before anything else, so you don't make that distributive error. 7 times 2x, 14x. 7 times minus 5, minus 35. 3 times x, 3x. 3 times minus 2, minus 6. 3 times 7, 21. So on the next test, if I see folks not get this right, I have to assume that it's a real careless error, but it's more likely that not looking at the videos and not practicing it in class. That's the stage of the term we're at. All right, so what's this become? 14x minus 3x, 11x. Minus 35, minus a minus 6, minus 29, all over 21. Let's try another one. Let's look at x squared minus 9 over 5 minus 2x minus 7 over 2. All right, bingo, bango, bongo, bingo. 2x squared minus 18, boom, boom. Bango, 5 times 2x minus 7 is 10x minus 35. 5 times 2 is 10. Okay, 2x squared, oh, there aren't any other x squareds. There's only one linear term, and so it's minus 10x. Minus 18, minus a minus, so 35 minus 18, 17. Didn't write that very well. And that's all over 10. And there's a quick check. All right, one last one. At this stage of doing them, you should be in good shape. So let's look at 5 minus a over, I don't know, 3 minus plus, what's the difference? A plus 4 over 4. All right, I'll put that there. Bingo, bango, bongo. 4 times 5 is 20. 4 times minus a, minus 4a. 3 times a, 3a. 3 times 4, 12. That's not so bad. I'm going to make this a minus. Nah, I can't because you're freezing the video and then watching. All right. And so that's 12 here, right? So I got minus 4a plus 3a is minus a. And I've got 20 plus 12, 32. Should have thrown some more minus signs in there, but that's what it is. All right, so that's hopefully enough practice to get you a couple of more correct responses on the next test, which will be Friday. So I hope you practice.